Greetings from SJBIT. Today we are going to see how to design a rectangular microstrip patch antenna for different frequencies. There are different methods of giving an input signal using inset feed or quarter wave transformer method, coaxial probe feed techniques, or proximity coupling, aperture coupling that we have. So in this session we are going to learn about the inset feed technique. Like you can observe is a patch antenna with length and width having the inset cut to match the impedance of the feed line with the patch antenna. So patch antenna has an impedance of around 190 to 200, whereas the feed impedance will have around 50 ohms. As these two impedances won't match, we need to provide matching by providing a cut. We call it as an inset cut and adjacent to the feed line. So in order to design that patch antenna, these are the basic design equations which we follow usually to design. Or you can go with means online calculator. You can go with online calculator as a uh, faster net Microstrip patch antenna calculator. So make use that. So once if you click on that, then you need to specify the specifications like which type of dielectric material we are using. If it is FR4, usually we choose FR4. The dielectric constant is 4.3 and the height of the material, height of the substrate is about 1.6 mm. So as it is in millimeters, choose that. As I am now supposed to design at 2.4 gigahertz, so calculate at 2.4 gigahertz the length and width of the patch antenna. So the length of the patch is 29.76 and width is 38.37. So as I have mentioned already, using the fasternet.com Microstrip patch antenna calculator, the length and width as I got to know, giving that as a parameter name specified as PL for patch length, PW for this one. Uh, as the patch is as the patch antenna is placed on the substrate, this substrate width or the ground, which will be below that we have a ground plane, both will be of same as the substrate length and width. So substrate length usually to be chosen as twice that of patch length, so around 30 mm if I choose 60 mm. The width of the patch substrate should be to double that of a patch width, so it is 40 mm if I choose 42 into 2, 80 mm. And thickness of the copper clad and height of the substrate. The height of the substrate, as I have chosen already, 1.6 mm. Thickness of the copper clad, indicating this copper material on top and bottom layer thickness is about 0.035 millimeter, which is a very length of which is very thin. Then feed it is a microstrip feed line. The feed width is chosen as 3.11 mm. So we need to calculate for a particular substrate the feed width, how much that you will get to have a 50 ohm connector to connect at this point. Then insert cut and insert width, insert length and width. So coming to this width, the width to be chosen as same as the feed line, half of the feed line width. Feed line width is 3.1 mm. So 1.5 I will choose on one side, other side 1.5, together giving about 3 mm. Insert cut length, the length of this insert cut, how depth of that to be chosen as lambda g by 4. Lambda g is guided wavelength. You can calculate that from the formula from the operating frequency. So I am supposed to design uh, microstrip patch antenna with at 2.4 gigahertz using FR4 substrate with epsilon r as 2.4.3, having the substrate height as 1.6 mm. So these are my parameters. So I can define that before I draw the structure, then give the input and observe the output signal. So now we'll start with designing the simulation part. So click on the desktop. You can find the CST Studio Suite. As it is a learner version, click on a new template. Then CST is not only meant for microwave application, other applications also it is. So choose antennas, then click on next, planar type which we are supposed to do, then go to next. Time domain solver I can go with, and the millimeter gigahertz which I will choose. As it is a 2.4 gigahertz, I will choose from the range of frequency to be chosen as 2 to 3 gigahertz. If you want, here itself you can monitor the fields like electric field, magnetic field and the far fields, or otherwise you can, after simulation you can go with. So these three fields which I am interested to, so I can mark that. click on next. These are the parameters which I have done. So cross verify once and click on finish. So once if you click on finish, you can find different windows. One is a navigation tree where you can observe the design components, along with that 1D, 2D results, ports, all those parameters. These are geometry where you will draw, and the parameter list followed by the progress. So coming to new parameters, here itself I will define the parameters. Patch length from substrate or ground plane. SL I will choose for substrate length, so which I have chosen here, which I have chosen is the PPT substrate length is 60 mm. Substrate length is 60 mm. Then new parameter I will define substrate width, which is of 80 mm. Then I will define thickness of the copper clad, which is of 0.035. Then new parameter I will define h, height of the substrate, as height of the substrate, which I will define it as 1.6 mm. And the new parameter I will define substrate ground is done. Then we'll go with patch length and patch width. Patch length is about patch length 29 point so 29.76, 29.76. Then PL I have done. PW patch width. Patch width is about 38.37. Let's verify once. 38.37. Then these parameters I have defined already. Now the feed width, inset cut width, and inset length, which I am supposed to. So feed width I am supposed to define. So FW, I will choose it as FW, which is 3.11 mm. I will tell you later how to choose that feed width as 3.11 mm. Then insert cut width. Insert cut width. Insert cut width is about half of the feed width, which is 1.5 mm. Then insert length. So insert length to be chosen as 7.16. For these two, I will tell you how to, or if you want to observe, these are the parameters I have defined. Substrate length, width, thickness, height, feed width, insert cut length and width, patch length and patch width. All the parameters I have defined. So 7.16. See, done. All the parameters I have defined now. Now I need to start drawing a geometry. So for that, start with a modeling. Local WCS cross verify once, because this indicates about coordinate system. Then I start drawing a geometry. So click on brick. In the modeling, you can find a brick. Choose a brick. Get like a dot. Escape. Then first I'll start with the ground plane. Given name is ground plane. So ground plane is same as the that of width and length is same as that of the substrate. So as I am starting at the horizon, so I need to see I need to start as I'm starting the geometry to draw from the center horizon on both the sides. So minimum and maximum will be minus SW by 2 to SW by 2, because I have defined width as SW parameter name. So parameter length as minus SL by 2 to SL by 2. Then the height is from 0 to the thickness of the copper clad. So T, choose the component name material from the library. So the copper which I am supposed to choose. So copper, anyone you can choose, load that material. So copper we have chosen. So now you can observe this is a ground plane which I have drawn. So similarly, upon that substrate I need to go to modeling, click a brick, then choose a escape. Then it will ask you the parameters, substrate, name of that. So substrate width is same as that of ground. So minus SW by 2 to SW by 2. Length is minus SL by 2 to SL by 2. Then thickness, now coming to the thickness, upon the ground you are supposed to start. So thickness T is the thickness of the copper. Upon that you need to place, so T plus the height of the substrate, T plus H. And the material is no longer copper, now it is Fr4 material. So choose on Fr, any one of that you can choose. Lossy type, which I have chosen. Here you can observe the parameters of that. Epsilon R value, which is 4.3. So Fr for lossy material, which I have chosen. Click on OK. So now you can observe. So this zoom in. So substrate, beneath you have a ground plane. So upon that, now I am supposed to create a patch. So click on brick again, then escape. So patch you need to draw. So upon substrate, patch length and patch width, as we have given already the name, PW by 2 to PW by 2. Sorry, PW by 2. Then again minus PL by 2 to PL by 2. So now keep in mind the ground plane beneath is the horizon. So now I need to move from that point to the top. So T plus H I need to move to reach to the top of the substrate. From there I am supposed to place my patch. So T plus H is the minimum. So T plus H plus T. Now the material is copper. So choose the one already you have chosen. So you can observe now beneath you have a copper ground plane substrate. Upon that you have a copper patch. So patch I have created. Now the feed line which I am supposed to give, again click on brick, escape. So the feed line which I am supposed to choose now. So choose a feed line. The feed line width is FW parameter I have defined already. So minus FW by 2 to FW by 2. And coming to the length of that is along the y-axis. So you are supposed to choose the width, length of the feed should match from substrate to patch. So substrate along y direction is SL. So SL by 2. Sorry. So SL by 2 to minimum to the patch, substrate to the patch. So PL by 2. So I should start from the substrate point to the patch point. That's why. So then the thickness means already height. T plus H is the minimum. Maximum will be T plus H plus T. The component is copper. The material is copper. Click on OK. Now you can observe the feed line which I have created. So the feed line you can observe. So now next step is creating an insert. So adjacent to the feed line in the PPT you can observe. See here, adjacent to the feed line you are supposed to create, or you are supposed to have a cut. See, this is called as an insert. So insert 1 and insert 2 or insert cut which I am supposed to do adjacent to the feed line. So for that, again first step is creating an insert here, then later deleting the portion of copper on the substrate, on the patch. So for that, first create a insert here. Choose a brick, then click on escape. So I am supposed to create an insert. So insert cut I am supposed to do. So insert cut which I am supposed to do it on left side as well as on right side. One side I will make, the other end I will make a copy of that. So the one end I will start with minus FW by 2. I should start from nearing to the feed line, no? So that's why. So FW by 2, 2. So minus FW by 2 plus minus, I am supposed to add a length of a width of insert width minus FIW insert width. So again insert length should be, So PL by 2 to PL by 2 minus IL, insert length. So thickness is same, so T plus H, I should start T plus H plus T. Material is copper, click on OK. Now you can observe the insert which has created nearer to the feed line on the patch. So same thing, I need to make a copy paste of that. So you can go with either choosing a brick and creating, or otherwise you can go for a transform. So the one which I need to go with the transformation is this insert. That's why click on navigation tree in the, under the components. So which one you need to insert cut, I need to create a copy of that. So click on insert cut, go to transform. I need to create a mirror of that, create a mirror. So along x direction I am supposed to, so that's why click on one, mirror plane normal, copy, unite. Then click on OK. Now you can observe copy paste which I have done. So now the next step is I am supposed to remove that portion, remove this insert from the patch. So from patch I am supposed to remove. First click on patch. How to remove means click on patch. So this is a patch. From patch I am supposed to remove. Click on patch. Then minus. Minus you can find it in a keyboard. Then insert I am supposed to move. Insert cut. Click on insert cut. Then click on enter. So once if you enter, now you can observe that portion has removed. So click on component. You can observe the component has got created with all the means a patch which geometry which has been created. Now the next step is giving an input signal. So how to give the geometry which I have created now? So full geometry you can observe. This is a ground plane, this is a substrate, then patch, this is a patch, feed line with insert cut. Next step is giving an input signal. How to give the input signal means zoom in. I am supposed to give at this phase the input. See, this is a substrate, this is a ground plane, and this is the copper clad of feed line. So this feed line I am supposed to choose. So you can go to pick face, pick any face or edge, pick face F. So I am supposed to select this face, double click on that. So as I have selected now, I am supposed to provide an input right now. So to provide input, go to home on a icon. So VBA macros. So in the macros, go to solver. Under solver, go to ports. Calculate the port extension coefficient. So now if you calculate the K value, here it is a microstrip structure. You can observe here I am supposed to give an input. I have selected already. So the K value for that is calculated. Construct a port from that picked face. So click on close. Now input I have applied, but it is not visible, hidden. So if I want to observe, so go to navigation tree under the ports. So port 1 which I had applied. So you can observe. So this is a port 1 which I had applied to the patch. Right? Right? This is a patch which I had applied an input signal over here. So now you observe component. This is a component I have, and this is a port. Sorry, this is a port which I had applied. Right? Now next step is input I have applied. Next step is simulation. So you can start simulation over here, or you can go to simulation, check the frequency range I had already given, click on OK. Check the background whether it is in normal position or not. Then go to boundaries. So you can check the boundaries which itself it creates boundaries for the patch which you have designed. Then start simulation. Start solver. Start setup solver. So no need to change any of these parameters, or if you want to go for change of parameters, you can go. Then start simulation. Once if it's start simulation, you can find the progress in progress window, and the results you can find that are the results you can find observe on uh, the results you can find it in 1D results as well as 2D results over here. As the field monitors which I have created in the beginning itself, no need to go for. So here you can find the field monitors which has got created at three different for three different iterations at 2 gigahertz, 2.5 gigahertz, and 3 gigahertz. So better not to choose any E field or H field for different point. Field monitors don't create at the beginning. So now the simulation got over. So once if simulation gets over, check for S11 parameter. S parameter represents about the reflection coefficient. So you can observe the patch is designed at 2.4 gigahertz, but we are not getting at 2.4. So nearly you can, if you want to go for marking, you can go for results only curve markers you can find. So mark at which point you are getting the minimum. So 2.33 gigahertz it is resonating, giving a less S11 value as minus 29.8. Bandwidth as you can define less than minus 10 dB. This is FL1, that means a lower cutoff frequency and upper cutoff frequency. So 2.3 minus the 2.377, around 770 megahertz we are getting a bandwidth. Now as we got to know, this is resonating at 2.33 gigahertz. So you need to create at 2.33 gigahertz the field monitors, which gives you uh, field monitor, new field monitor you create. Reason, the frequency which is resonating is not at 2.55, at 2.33. I'm supposed to observe electric field or magnetic field. Click on apply, click on apply, it's at 2.33. Even far fields I'm supposed to apply at 2.33. Even the field source I'm supposed to apply at 2.33. Click on OK. So now you can observe, yes, I am supposed to replace it. See, so these are the field monitors which which I have created at 2.33 gigahertz, because my structure is resonating at my structure is resonating at 2.133 gigahertz. Once if you create a new field monitoring, so you need to go with the simulation again. If you, as you have created new field, new monitor, so I am supposed to go for simulation at that particular frequency. Once if you do, then it will show you the 2D or 3D results. Far fields you can observe along with that electric and magnetic field variation, animation of that, directivity, gain, efficiency, all other parameters you can find out. 1D as well as 3D, 2D results. So as the simulation got over, 1D results I'll start with. So under 1D results in the navigation tree, so you can find out S parameters. So this is a S parameter which I have already seen. Similarly, if you want to go with the Y parameter, VSWR also you can go. So you can create a curve marker. So as we know, minimum value is 1. So as I have got here 1.06 at resonating frequency. So S11 VSWR I have seen. Next parameter I am supposed to see is 2D 3D results along with far fields. So coming to electric field 2D results, I am supposed to observe at resonating frequency. So you can observe for the variation of electric and magnetic fields. So instead of having arrows, go for contour. You can observe easily structure transparent. Go for animation. You can observe the power flow, or the, you can zoom out, zoom in, and observe how the signal, how the electric field will propagate. So you can observe the electric field which is maximum along the width, length compared to length. You can observe in the same way magnetic field. So if I go with the magnetic field, so you can observe, so this is a magnetic field animation which I have chosen. So along the length you will have. So similarly you can go for surface current variation. So surface current, how it is flowing, you can observe here. Even with arrow marks or with any of that you can observe. See, red color one indicates where you will have a maximum at the center. This is about electric magnetic field observations, then followed by far field and far fields. So go for far fields. So stop animation. Electric field also. Stop. We have stopped animation. Then go with the far fields. So in the far field, I am supposed to go at 2.33 gigahertz. So you can observe this is a far field analysis. Far field radiation pattern. As the structure is not visible, you can observe this is a structure where you have placed this and minor lobes, and this is a major lobe. And here you can observe the fields. It's a directivity. Maximum value which you are getting is 6.76 dB. Or you can observe here instead of 3D plot, go with a 1D plot. Clearly you can observe. See, go with a 1D plot. So, in 1D plot, you can find the far fields. It is at 2.33 gigahertz. So, the major lobe magnitude which you are getting is 6.77 dB. This is a directivity far field curve. So, if I want to go with other parameters, like instead of far field means 2D results which I am interested in. So if I want to go with directivity gain, so this again gain you can observe it's just 3.08, whereas directivity which you are getting is 6.77. So instead E field pattern or H field pattern you can go with. So this is electric field pattern. This is a structure where you have. Similarly, H field pattern you can observe. See, what you can conclude from this is it is a broadside radiation pattern. So if I have an antenna along this axis, broadside radiation pattern you can observe. So one more parameter variation. This is about observing the results. One is directivity, electric field, magnetic field, and along with that gain. Then S11 parameter we have observed. So the next parameter you can observe similarly. Parametric analysis you can go with. See, as we have say 3D structure, means 1D results. If you go with 1D results is one parameter. So as I have designed at 2.4 gigahertz, but I have got at 2.33 gigahertz. How to change the resonating frequency? So the resonating frequency which will get affected by the patch length. So that parameter I will change accordingly. For that, how to go? Go to parametric suite. So new sequence I am supposed to define. New parameter I am supposed to vary. So patch length I will vary to have a variation. So I will go with the 20 from 28 millimeters to around 30 millimeters. I'll go with. So how many samples? 2 samples or 3 samples I'll go with. So if you click on OK, these samples has got created. You can start simulating. Then once if you start simulation of these 3 samples, you can observe the 1D curve for different parameter of patch length. So it is getting simulated like this. Different parameters you can vary because the insert cut, insert length and width, along with that substrate length and width you can vary and observe for the variation in S parameters. Now you can observe the two curves. First curve which we have done at 29.76 original means calculated patch length. And this is another one patch for a patch length of 28 above. The patch resonating frequency which we have got as around 2.45 or 2.5 gigahertz. See, exactly this is the one which is giving 29. For 29 mm you are getting exactly 2.4 gigahertz. So if I choose 29 mm as a patch length, the remaining parameters the same as it is, then you will get and you can observe the good around 45 minus 45 dB. So good match also which you are getting. This is what the results shows. So this blue color one you can observe for a patch length of 29 mm around minus 45 dB. Curve markers if you want to go with, you can go with a curve marker. So you are getting around minus 45.9, 46 dB, which you are getting minus 46 dB, which is having a very good match. So with the patch length of 29 mm, you'll get a good results. So now one more I told you to how to find out the feed width as 3.1 mm, 3.11 mm, or inset length as 7.16 mm. So in order to know about that, so you go to home. In the home, go to VBA macros, calculate. So analytical impedance, line impedance calculator you can make use. So any of this you can go with. Thin one, which I am supposed to, with this thin one I am supposed to make use. So as I am supposed to design at 2.4, so choose that frequency, and the height I have chosen as 1.6 mm, the height of the dielectric substrate, and the epsilon r value is 4.3 mm. So include dispersion, that is a tangent, last tangent. So with the width, suppose if I choose this width, the feed line width as 2 mm, you calculate the impedance at that frequency. At that means with these parameters you are getting a 64. But as we know, I am supposed to have impedance as probe impedance as 50 ohms. In order to get that, I make a trial and error. So 2.5 mm if I choose, and if I calculate, I am getting as 57, nearing. So around 3 mm if I choose, so then you calculate, you are getting 51. So I'm nearing to that 3.12 or 11 if I choose, I'm getting around 50 ohms. So I can go with the 3.12 mm as the patch width. Similarly, you can calculate for the inset width. Half of that for the width, length should be double to this. So 3.1 to 7.16 mm. Understood. So exit. So we have created the geometry and seen the results, 1D 2D results, S parameters as well as far fields, directivity, all the parameters we have seen. With this we have designed a rectangular microstrip patch antenna at 2.4 gigahertz with these specifications. Thank you. Hope this video might help you out. Thank you.